Okay, so if you remember at the start of the first video, I pointed out the difference between what the first video is on and what this video is on. These are quadratic inequalities in one variable. There is no y in any of these equations. So whenever you see just one variable, just x's, this is the technique that you're using. It's going to be like a number line answer basically. So solving ax squared plus bx plus c is less than 0. We want to know for what values of x would this left side come out to be something negative? Or for this one, we want to know for what values of x would this left-hand side come out to be something positive. So since we've dealt with the graphs of parabolas before, we're going to use them to help us. Okay, so what we're actually looking for, and a way that we can do this is we can give a quick sketch of the parabola, and then we're trying to identify where we come up with negative values. And negative values would be below the x-axis. Okay, so what we're trying to figure out is when the parabola would have negative values, aka when the parabola would be below the x-axis. So we've got two scenarios that could happen here. Scenario number one is we've got a right side up parabola. Scenario number two is that we've got an upside down parabola. And I'm doing just these very, very generic graphs here. So if we want to know for which x values is the graph below the x-axis, the first thing you find is for which values the graph is on the x-axis. Those are your very important starting points. Okay, so again, our goal is to find for which x values our graph is below the x-axis. So here, I'm below the x-axis for all of this. So my answer would be all of these x values. So for any x values in this range, my graph would end up below the x-axis. So anything that I plug in between here and here, my graph ends up below the x-axis. So my goal when I start working through these problems is to figure out what that range is. If my parabola is upside down, I would be below the x-axis for all the x values over here, here and to the left, and this actually keeps going because this will keep going down, and so this will keep going, and then this wing over here, and same thing, this will keep going. Okay, so we're trying to find the x values. Remember, we're just in one variable, so our answer is just going to be on a number line. Okay, so very similar situation here. We're trying to find for which values of x do I come up with positive values. So for a visual, we can look above the x-axis. So again, we want to know for which values of x would my parabola end up above the x-axis. So this time I will do my two scenarios again. I have a parabola that's right side up, and then you could have a parabola that's upside down. Okay, so to find where it's above, the first points we will start with is where it's right on the x-axis. Okay, so this one is above the x-axis over in the left wing, over in the right wing. So any of these x values that I plug in from here over, and again I'm going to put an arrow on this because it would keep going since this keeps going. And then same thing from this point over to the right. This would be above the x-axis. This one is above the x-axis on this little hill right here. So between this x value and this x value, if I plug those x values in, my graph would end up above the x-axis. So hopefully this gives you a nice little visual for what we're looking for. So let's take a look at some of these. So solve this by graphing. So I told you up here, it's super, super important to know when we are on the x-axis. Okay, so for solving by graphing, we absolutely need our x-intercepts first. And we need them. It doesn't matter if it's factorable or not factorable. We will see an example where it's not factorable. But we're going to try, because factoring is usually easier than any other method. So we need our x-intercepts, which means we need to start by setting this thing equal to 0. Okay, so let's see if it factors. We can start with x and x, because we know that'll give us our x squared here. And then these two numbers, they have to multiply to 3 and add to -4. Means they're both going to be negative, first of all. Two negatives multiply to a positive and add to a negative. And it's going to end up being 3 and 1. Okay, so I can solve this. If I set x plus 3 equal to 0, I get 3. If I set, x minus 3. If I set x minus 1 equal to 0, I get 1. So we are going to give just a quick sketch of that graph. So we've got intercepts at 1, and then again at 3. And then the next thing we need to know, all we need to know for just this quick sketch, is whether it's upside down or right side up. So a, the number in front of x squared, is technically just a 1. So since a is positive, my graph is opening upward. Okay, so I just need a quick sketch. All right, it's going to look something like that. Okay, so we start with a quick sketch. What I'm trying to figure out is less than 0. I want to know when my graph would be below the x-axis. So you can kind of trace back up to here. We've got less than 0. We're dealing with a right side up parabola, so it's going to be these x values in between the intercepts. Okay, so what I'm looking for is this range of x values right here. Okay, for any of these x values, if I plug them in, I end up below the x-axis, which means if I plug them in, I come up with a negative value, which is what I'm trying to find here. So in words, we can say it's anything between -1 and 3. I'm sorry, between +1 and 3. And in inequalities, we would write that as a 3-piece inequality like this. Okay, so this says anything between 1 and 3. If I plugged in any of those x values into this inequality, it would come out true. Now notice I just have the less thans here, and that's because this is just a less than. These would have or equal to's if this had an or equal to. So this would be your final answer here. Okay, let's look at another one of the graphing ones. Okay, so this one, I mentioned, we need x-intercepts no matter what, even if we can't factor. Now this one, just looking at it, you might not even want to try to factor. It doesn't work out. So we can find the x-intercepts by using the quadratic formula. Okay, so we are going to use the quadratic formula to find the x-intercepts. Okay, so we want to take the -2x squared minus 6x plus 1, we want to set that equal to 0. So we do x equals, first part is negative b, so b is -6. Negative b would be +6 plus or minus square root of b squared minus 4 times a times c, and then all of that over 2a. So 2 times -2 would be -4. So I can just plug this thing into my calculator because I'm going to get decimals. This is the one and only time where you actually do want to get decimals for your approximation. So I'm just going to plug this in. So -6 quantity squared, make sure it's in parentheses, minus 4 times -2 times 1. So I have a 44, which proves to me that we were right in thinking that it didn't factor, because a 44 is not a perfect square, so this is going to give you irrational numbers. So here's what we do. We want the plus or minus, so we can start with 6 plus the square root of 44, and then divide that by -4. So we have about 3.2, -3.2. And the next one, I can take 6 minus square root of 44 and divide that by -4. So that gives us about positive 0.2. Okay, so just one decimal is fine. We're just trying to get an approximation. So these are my approximate x-intercepts. So I can start there. So I've got 1, 2, 3, 4. So -3.2, you're just estimating. So right around there. And then positive 0.2, again, just estimating. So it would be right around there. Just do your best. Figure out which two numbers it would be between. Next, for this parabola, since a is negative, a is a negative value. We've got a -2, so this means that it opens down. Okay, so just a sketch tells me it looks something like that. Okay, so it looks something like that. Now, this is a little weird because this is kind of written in reverse order. So if I write this with the equation on the left, if 0 is less than the equation, that means the equation is greater than 0. So I've got this right there. Okay, so in between my two x-intercepts is where my graph is positive, where it's above the x-axis. So I want these values in here. So very similar to the one that I just had on the previous page. So it's everything in between those two. So starting at -3.2 is less than x, which is less than 0.2. This is what tells us it's everything in between. And then the fact that this has the or equal to means that these have the or equal to. Okay, we've got this example right here, and I'm going to teach you how to use your calculator to get these intersection points. Okay, so we are looking for this equation right here. And then it says, during what interval is the rocket at least 100 feet above the ground? So we're going to take this equation, and we want it to be at least 100 feet above the ground. So that's a greater than or equal to. I know the word least can be misleading, but at least means that much or higher. So start by subtracting the 100 from both sides. And so I get negative 16t squared plus 82t, and then this would be minus 99.75. So we start by finding the x-intercepts, and we are going to do that on our calculator. So I want you guys to open a graph page, and when you do that, just plug this in, except instead of t's, you need to plug in x's because your calculator will only recognize x's. So negative 16x squared plus 82x minus 99.75. Then go ahead and hit enter. And you'll see your graph. It's right there, just this little loop here. So we want to find the x-intercepts, and I'm going to walk you through how to do that on your calculator. So hit menu, the menu key, and you should probably do this with me so you know how to do it. And then the sixth option is analyze graph, so hit 6. And the first option is 0. 0 is the same as x-intercept, same as roots. And so you're going to use this little touchpad, and you can kind of move back and forth. So when it says lower bound, like we're going to identify this one first. You just get somewhere to the left of that first x-intercept and then click down. And if you do it right, it should change to say upper bound. And then drag over here. And then once you get to the right, click down again. And you can see right there that my x-intercept popped up, 1.99. Okay, so I get 1.99, that's the first one. And then repeat the process. So again, hit menu, hit the number 6 for analyze graph, number 1 for 0, and then do it again, but this time we're going to catch that second one. So start somewhere to the left of it, click down. When it asks for the upper bound, drag to the right of it, click down again, and that gives me 3.14 as my next one. Okay, so I'm going to do a quick sketch. Going to graph my intercepts. So 1, 2, 3, 4. 1.99 would be like right there. And then 3.14, you're just approximating. And we know what this graph looks like, so we can do a quick sketch like this. Okay, it wants to know when we're greater than or equal to 0, so that would again be this region in here. Okay, everything between those two x values. So we can write it as a 3-piece inequality, just like we have been. This one does have the or equal to's, only because this one does. Okay, so now we learned kind of 3 different techniques, factoring factoring quadratic formula, and then the calculator. We're going to do sort of a separate technique for these last 2 problems. So solve each inequality algebraically. So first thing we need to do with this one is move the 2 over. So this one we're going to do it without a graph. We're going to do it on a number line. So we still start by factoring because we still need to know the x-intercepts. So this is always your first step. So start by factoring this if we can. We're going to hope we can. Okay, so actually, I'm sorry, we want to start by finding when it is equal to 0. So that's what we're working on right now. So we want to know what multiplies to negative 2 and adds to positive 1, and that would be a positive 2 and a negative 1. Okay, so my x-intercepts, when I set this one equal to 0, I get a negative 2. When I set this one equal to 0, I get a positive 1. Okay, so what I'm going to do here is I am just going to set up a number line. Okay, so we're going to do this without a graph this time. And just put the numbers in order. So negative 2 would be on the left, 1 would be on the right. So I know that these are the only 2 places where my graph would be equal to 0, which means it splits me up into 3 different regions on the number line. These are the numbers less than negative 2. These are the numbers in between, and then these are the numbers greater than 1. So since I'm only 0 right here, my x values should be all positive or all negative here, all positive or all negative here, all positive or all negative here. So what I do is I do a test value. I pick any sample number that I want in each of these regions and test to see if it's a solution to this equation. Okay, so we can test, here we could test like negative 10, something in this region. Here we could test 0. 0 is super easy. And then here we could test, I don't know, 3. So you're just picking some sample value in each of those ranges. So we're going to plug negative 10 in here and see if it's true or false. So negative 10 squared plus negative 10, does it come out to be less than or equal to 2? Okay, so this is 100 minus 10. So is 90 less than or equal to 2? No, not so much. So since this is not a solution, I'm going to write that this is false. If I try to plug in anything over here, I get a false statement. Okay, so let's try to plug in 0. So is 0 squared plus 0 less than or equal to 2? So is 0 less than 2? Yes, it is. So if I plug in anything in this region, my inequality is true. And then let's test something like 3. 3 squared plus 3, is it less than or equal to 0? This is 9 plus 3, which is 12. 12 is not less than 2. So that means if I pick a sample value in here, I get false. So what I want is what makes it true. So that would be this region in here. Okay, so that would make it true. So I just write it as a 3-piece inequality. So anything between negative 2 and 1. This does have the or equal to, so these do as well. Okay, we're going to look at our last example for chapter 4. So same thing here, we're going to start by factoring this down. Start by finding your x-intercepts. So I'm going to take this and set it equal to 0 to find my x-intercepts. I want to start by at least attempting to factor and hope that it works. If it doesn't factor, you could still do the quadratic formula on these types as well. So we want to know what multiplies to 30 and adds to 11, and that would be a positive 6 and a positive 5. Okay, so my intercepts are negative 6, if I set this equal to 0, and negative 5. Okay, so we're going to set up a number line, just like we did before. Put the numbers in order. Negative 6 would be on the left, and then negative 5. And so what these numbers do is they split my number line into 3 different regions. Okay, so I can test 3 different values. Okay, so over here, and let's test, I mean, you can test literally whatever you want. Like we could test like negative 100 if we wanted to, something over here. Here you're going to have to pick a decimal somewhere between negative 5 and negative 6, so maybe like negative 5.5. And then 0 is in this range. You always want to pick 0 if you can because it's so easy. So negative 100, if we square negative 100, we're going to get 10,000 plus 11 times 100, so minus 1100, and then plus 30. Does that come out to be greater than 0? And I hope that you can see that it definitely does. Definitely greater than 0. So when I plug in something over here, anything over here, I get a true statement. Okay, now let's plug negative 5.5. So negative 5.5, if I square it, you could definitely use a calculator for that. You come up with 30.25. 11 times 5.5, negative 5.5. Again, I'm going to plug that into my calculator, and you get negative 60.5, and then plus 30. So just barely this actually comes out to be negative, because these together are 60.25, and this is a negative 60.5. So no, this does not come out to be greater than 0. So anything in the middle would be false. And then finally I can plug in 0. 0 plus 30 is 30 greater than 0, and of course, yes, it is. So this would give me a true statement over here. All right, so I want the true statements. So I want everything over here, and I want everything over here. Okay, so this is going to be a disjointed set. So this set right here is anything less than the negative 6. And it stays just less than because this doesn't have the or equal to. And then or anything greater than the negative 5. Okay, so 2 different techniques there, kind of a lot to absorb, but that is the end of chapter 4.